So, hello everyone. I think you all would be there. ABCD discussion we had with Aditya Mr. And we will be doing EF and G discussion with Dhruvil Kakadia of the yesterday's session of our camp, yesterday contest of our camp. So, let's begin with the discussion lecture with Dhruvil.
So, hello everyone. Am I audible to you first? Let me know. Wait a minute. Uh, okay. So, let's start with the problem E. In problem E, what is given? Like Alice and Bob are playing a game, and there are n balls, and out of that, k balls are special, and each ball has some value with it. And it is given that the first k balls are special, and what they are doing, they are playing turn by turn, and Alice will go first and he will pick a ball and add the value of the ball in their score. And if the ball is special, then the turn will not change. Like Alice, there are some balls, and let's say here is the special ball. Then if Alice will pick this ball, then the turn will not go to Bob, and if Alice will pick this ball, then add the value of it to Alice score, and the turn will go to Bob. So and we have to find the expected score of the both player modulo 10 raised to 9 plus 7, and there is some things written in formally, and k is less than n, and n is up to 4 into 10 to power 5, and the value of each ball is up to 10 to power 7. And so let's try to understand the first example. It's a 5. Okay, wait a minute. Yeah, okay. So there are 5 balls, and out of them first 2 balls are special, so 10 and 20 are special, and rest of the 3 are non-special balls. So what Alice will do, Alice will come first and pick one of these balls. Let's say he pick 5, then 5 will add it to Alice score, then the turn will go to Bob. Let's say Bob picked 20, then 20 will be added to Bob's score, and if the 20 is the special ball, so Bob will uh, so the move still remains with the Bob, and Bob has chance to pick ball again. So Bob, now let's say Bob picked a ball 25, then his score will become 20 plus 25. So that's how they are playing. Like first Alice will go, then if he pick the special ball, then again the move will be with Alice. Then let's say again he picked the special ball. Then again the Alice will take move. Now let's say he picked a non-special ball. Then Bob will pick one ball. Now let's say again. Now let's say Bob picked a non-special ball. Then again Alice will pick some random ball. So that's how they are taking turns, and we have to find the expected score of both. So let's say first, let's see that there is no special ball. Like there are balls like 10, 25, 15, 25, and k is equal to 0. Then what will be the formation of the game? Alice will pick one ball. Bob will pick one ball. Again, Alice will pick. Bob will pick. Alice will pick. And in the 5 turns, the game will end because there will be no ball remaining. So what will be the answer for this? So now let's say what is the probability that Alice will pick some ball? So there are 5 balls. So Alice will pick one of the 5 balls. Now Bob will come and he will pick one of the 4 ball. So that's how we calculate the probability when there are five ball and we are picking one ball out of them. So let's say how many balls at the end Alice will have and the Bob will have. So at the end, Alice will have, you can see uh, they are playing in turns and Alice has the first move. So Alice will have n plus 1 by 2. Uh, Alice will have n plus 1 by 2 balls at the end, and Bob will have n by 2 balls at the end. This is in floor and it's a seal. Okay, so let's say this is x and it's y. So we can see that Alice will have x balls and Bob will have y balls. So what is the probability that Alice will pick some ball? So we can say that probability that Alice will pick a non-special ball, it's x divided by x plus y, right? And what is the probability that Bob will pick some ball? So we can say that it will be 1 minus x by x plus y. And for simplicity, you can just say it's a y by x plus y, right? So that's the case for non-special balls. Now, the case of non-special balls and the special balls are totally independent. And after, now, so let's see how we calculate expected score from the probability for the non-special balls. So let's say Alice, the, uh, what we'll do, we will just find probability for Alice or Bob. Because from one of them, we can just find the probability of another by uh, removing them from one, like we did here. So now let's say what is the expected value of Alice will pick a some ball. So the probability that Alice will pick some ball is x by x plus y, and the expected value will be into v of I, because we are picking every ball with this probability. So expected value will be multiplied by value into probability is the expected value. So that's how we will get probably expected value of Alice. And if we find for Bob, then the expected value will be, let's say, uh, if we go by this like a y by x plus y, it will be easy to calculate. So the expected value for Bob will be y by x plus y into vi for non-special balls. And now we counted probability for non-special balls. Now let's see how we add the contribution of special balls. So let's say, so there are k special balls, and uh, let's say these are the places where Alice and Bob picked non-special box, non-special balls. Like Alice picked from here, and then some special balls here. Then again move turned, and Bob will pick. Then Alice will pick. Then Bob will pick. And at these spaces, there are special balls. So let's say the number of non-special balls are n minus k because we have k special balls. So number of these empty spaces is n minus k plus 1. So what we have? We have n minus k plus 1 empty spaces. Let's say it's some value c. Then let's say we have c spaces, and we are putting some special balls here, and we have to find that how much it will contribute to each of the player. Now let's say uh, if this place is for Bob, this place is for Alice, then Alice picked a non-special ball here, then move will change and Bob picked special ball here, then again Bob picked non-special ball here and move will change, and again Alice will pick. So that's how this formation is built. And we can say that there are n minus k plus 1 by 2 species where Alice is picking the special balls, and n minus k plus 1 by 2 which is a floor, and it's a seal for Alice because Alice is going first, so Alice will have one extra space at the end. Uh, let's we saw that here, like Alice will have one extra ball at the end. So again, we can say that like we did not for non-spatial balls like X and Y. So it's the same case. Like we now know, like let's say it's a new X and new Y. So again, the probability that Alice will pick a special ball is new X. Alice will pick a special ball in some place is new X by new X plus new Y. And the Bob will pick a special ball is new Y divided by new X plus new Y. And you can find that this thing expected value for Alice like a new X plus new X divided by new X plus new Y into Vi for each ball, each spatial ball, and this is for Bob. So ny by nx plus ny into Vi for each spatial ball, and add this to the previous answer, and it will be our final expected value. So, do you guys have any doubt in this? Like, or can I show the code? So, do you have any doubt? Just ask in the chat. Okay, I think the problem is clear to everyone. So let's move to the code. So here is the code that I submitted. So what I did, I sum up the value of every special ball. Like there is thing mentioned that the first k balls are the special balls. So I created two sum and sum out the first k balls as the specials is sum one and denoted the sum two as non-special ball. And what I did, like I know like there is n minus k non-special balls. So my value of so let's see one thing here again. Nx plus ny is number of total balls, right? So number of total nx plus ny is again n minus k plus 1. So I know nx plus ny is n minus k plus 1. So and in the modulo theory, we have to uh, count the inverse if we are dividing some number. So I counted the inverse. TMP is my n minus k, so n minus k plus 1, and the inverse is mod minus 2, power of mod minus 2. So I counted that inverse, and I counted the answer like, let's see. So I divided that TMP by 2 plus 1 is my nx, right? N minus k plus 1 by 2 and seal of that is my nx. So I did that here and multiplied the inverse that I found. So I got the term nx by nx plus ny, and that I stored in OK1, and I just multiplied it by sum 1. That's my answer for non-spatial ball. And if I have some spatial, like if this condition doesn't matter, and if I have some spatial balls, what I did, like now I know there are n minus k spatial balls, and the value of x plus y is equal to n minus k. So I counted the inverse again, like for n minus k to the power mod minus 2. And again, I multiplied it by TMP minus 1 by 2 plus 1 for seal purpose. And it's again my x n plus 1 by 2 seal. And that thing I again multiplied with the sum of non-spatial balls, and I added that to my answer, and it was my answer for Alice. Now what I did for my answer two, the as I told, like if we have one answer, we can get another by just removing it from total. So the total answer is sum one plus sum two, and I removed the answer the expected value for alias from that, and did like I'm removing that, so I'm adding mod here to get positive answer, and did a mod again. So that's my answer for Bob, and that I printed, and I got ASCII. So the problem is like uh, so the problem is like very easy term for probability. If you know the probability, like in JE preparation or elsewhere, you found it like you are picking a ball in turns, and you are finding the probability that how many balls you picked, how many red balls you picked, white balls you picked. So the problem is related to that, and I found that problem not very interesting, but yeah, it's a good one if you are beginner and finding the problem related to expected probability thing. Okay, someone mentioned that I forgot to use linearity of expectation, so I instead use a loop simulating the number of special and non-special balls left after each move. Yeah, that will work, I think. Yeah, that will work if you are doing a loop for simulating the special and non-special balls. Uh, Okay, I think the problem is clear to everyone and the implementation as well. Like for a simplicity of application, you can do that X and Y and NX and NY thing and implement it simpler. But I got an idea in my mind too early, so I just coded seat, I think. Okay, so idea is clear to everyone, right? What's your doubt, Mukul again? Special balls you can choose multiple times, then EXP again. Uh, what do you want me to explain? Okay, is it? Uh, yes, for special ball for what? Yeah, expectation. I think you can find if you have doubt in expectation, then maybe you can read out a blog from Pasca. Let me attach the link of that. Okay, I'm attaching the link of the blog if you have doubt in expectation. Okay, and let me try to explain it again. So what are we doing for non let's say here are these places where Alice and Bob picked non-special balls, like Alice picked here, then Bob picked here, then again Alice picked non-special ball here, and Bob picked non-special ball here. So what is the for probability of formation? Like there are these places, like let's say there are n special balls, then I will have n plus 1 species for special balls. Like I have n non-special balls that are picked by Alice and Bob alternatively, then I will have n plus 1 species for special balls. And uh, the probability that Alice will get some special ball, and Bob will get some special ball is again n plus 1 by 2, because let's say what is the thing can happen, like Alice picked some special balls here, then he got into non-special balls, then Bob picked some special balls here, then he got non-special balls. Again, Elias got some special balls, then he got non-special balls. Again, Bob got some special balls, and then he got a non-special ball. So that's why Elias will get n plus 1 by the seal of n plus 1 by 2 special balls, and seal of n plus 1 by 2 non-space spatial floor of n plus 1 by 2 will go to Bob, right? And we have and the probability that Alice got these and Bob got these is again, like, you consider these x and y, then it's again x by x plus y. X plus y is again n plus 1, and Bob got the special ball is y by x plus y, let's say n plus 1, because x plus y is equal to n plus 1. And that's how the thing works. And the expected value is expected value for, like, let's say it's a probability p1, then expected value that Bob got v that ith special ball is p1 into vi, and the sum of it will give me the expected value that Alice want. So I can count sum of vi first and then multiply it by p1, or I can do it by running a loop. So I hope it's clear to you now, Mukul. Okay, let's move to the next problem. So the next problem, f is array value, and what we are given, we are given us array a of the length n, and there is what is the cost of subarray, or if subarray size is greater or equal to 2, the minimum value of ai xor aj such that I and j is in the subarray L to R, and we have to find the kth smallest value over all subarray in the given array. So let's say how we can. So let's see what is the question first. We are given an array A and for an subarray, like here is my subarray A L to R. For this subarray, the cost of this subarray is equal to minimum value of AI XOR AJ such that I and J is in the range L to R inclusively, like L less than equal to I less than equal to, it cannot be same, I less than J and R. So the cost of this array is like any, you pick any two elements and do a XOR of them, and from every possible pair in the array, the minimum value is the cost of the array, and you have to find the, I hope I right, yeah. That minimum value is the cost of the array, and you have to find the kth smallest value over all sub-array. Now, we know that in a array of length n, there are nc2 sub-arrays, right? Uh, but let's say how we can do that, do it optimally. Like, you can do it for every array. If you brute forcefully, what you can do, like traverse every array and find the cost and return the kth smallest value by sorting those values, right? That's the brute force way. But let's try to do some kind of greedy thing here. Let's say I have one okay, wait a minute. First of all, do you know, uh, let's try to solve one thing. If I'm given one array A equal to, let's say, a random array 5, 3, 1, 7, 10, then what is the maximum value of pair AI XOR AJ from this array A? Do you know this? Like, let me give answer in the chat. Like, how to find it optimally, ai xor j, minimum value of ai xor j from any array you are given. Like, your You don't have to find for entire array. Yes, Ankit mentioned that using try. Okay, try is one of the way, but everyone doesn't know try. So I solve the problem without the try. So I want to explain the other way and the one property of exo here. So do you know how to find these using exo property of an XOR? Like solution is again n log n. If you use try or the thing I am going to describe, but yeah, let me know if you know that. No, I don't want the answer. I want to know that how you will find that in optimal way without using try with by using some property of XOR, because it will help us in the original problem, and I'm going to explain the solution in that way. Okay, I think you guys don't know. Let me explain. So let's say I have three numbers A, B, and C. I know that A is less than B and B is less than C. Then what two pairs will give me the minimum answer? Like there is a beautiful property that A XOR B and B XOR C. The minimum of this will be always less than equal to A XOR C. That's a property of XOR. And I'm leaving the proof to you guys. So just knowing this thing is a great help for this problem, because you know you have three adjacent number. Then the minimum value will be XOR of two adjacent number. Like I say, here is one unsorted array, and I want to find the minimum of two pairs I and j from here. So what I will do, I will just sort the array. The sorted array will be 1, 3, 5, 7, and 10. And if I do XOR of two adjacent numbers, then the answer will be from this four value, just because of this, because if a is less than b and b is less than c, then XOR of ab and XOR of bc is always less than the XOR of a and c. So this can help us here. Like I have one. Okay, you got what I'm trying to say for a single array? Then I will move to the final answer. Write yes in the chat box so I can continue with the answer. Okay, great. So now we are trying to find the kth smallest value. And if we find that for some value x, there exist some, there exist, let's say, y subarray that has XOR less than x, that has the cost less than x, and y is less than or equal to k, let's say, then I can say that yes, my answer can be yes, x. And if for a value x, if number of subarray y is greater than k, then I can say that answer x cannot be possible, and I have to find some smaller answer first. Do you get that? Like what I'm trying to say? Okay, I think I explained it in a wrong way. Like, okay, forget it. Uh, let's say you have an fixed value x, and you have to check that for this x, is there exist some sub-arrays, and you have to count number of sub-arrays, that is the cost equal to x. And if the count of the sub-array is equal to y, like let's say count of sub-array which has cost equal to x is y. Then if y is greater than equal to k, then I can say yes, x can be the answer. Because I'm not saying x is the answer, but I can say x can be the answer because there are more than k or equal to k subarrays that has the cost x. And if I find the value that is, like if I find some value which is greater than x, then again it's obvious that there will be y. Uh, for this value, the new y will always be less than this y, right? So from this observation, I can do a binary search on the answer. Like I will check value mid. Is value mid is possible in at least k sub array or not? And if it is, if it exists, then what I'll do, I will go for some smaller answer, right? You got that? What I'm trying to say? Like we are finding the kth smallest value, and if it exists in k sub array, it means that it can be our answer. I closed chat box. Wait a minute. Yeah, yes, yes. Binary search is what I'm trying to do. So now I know that binary search is applicable on the answer. And the proof I discussed, now we have to implement the checker function of it, like is made possible or not. And now let's say uh, I have some fixed like I am in this position in the array. Let's say it's my right boundary. And now, if I found the left boundary L such that the cost of this interval is equal to mid, or cost of this interval is less than mid, let's say, less than or equal to mid, then I can say that the cost of every array that ends at R and starts from any position at in the range 1 to L. Like let's say here is somewhere my L can lie. Like for this every L sub arrays, I can say that they cost answer equal to mid in the end, because if I decrease the L, answer is increasing. So I can say that yes, if I go towards the right, the cost will decrease. So these sub arrays are my valid sub arrays for mid. Is it clear? If you have any doubt like what I just described, just let me know. Okay, I think no one has any doubt. So it's something like a sliding window over here. Like we are for a fixed value of r, we are finding an L which has the greater value than r. Now let's see how we can do that. Like array is not sorted, yes, right? And if array is not sorted, then we this property is no use. But let's say we can use the sorted values for the array. How? We just store every value in the multi-set, and let's say we have two multi-sets. Okay, set 1 and set 2. This multi-set is storing every value in the current window size, and it will be sorted, right? And it can contain duplicate values. And the other set, I will store the value of adjacent XOR pair. Like let's say in my current S1, there are three values, 1, 2, and 3. Then in my other set, I will store the value of two adjacent XORs. Like let's say 1 XOR 2 and 2 XOR 3. It will be sorted, right? Like 2 XOR 3 is 1 and 1 XOR 2 is 3, right? This will be my S2. Now, whenever I add any value to the S1, like let's say I added, uh, let's say here is 4, not 3. It's a 4 XOR 2, and okay, it's 3 and 2 XOR 4, 6. Okay, something like this was there. And I'm adding, I want to add 3 to the my current set. Like I found that in the next position at R, I have value equal to 3. So I have to add 3 in my sorted array. Like this multi set is my sorted array, right? And in this sorted array, if I'm adding 3, then what I have to do? Like if the position of 3 is this, then I have 2 and 4 is no longer adjacent. Then I have to remove the XOR of 2 and 4, which is 6, from the S2. So I will remove 6, and I have to add the XOR of 2 and 3 and 3 and 4, because 2 and 3 and 3 or 4 are now adjacent. So the XOR of these two will be added to S2. And similar to that, if I have to some XOR, remove some value, like let's say S1 is like 1, 2, and 3, and my S2 was 1 XOR 2 and 2 XOR 3, 1 and 3. Now let's say I'm removing 2 from it. Like it was at my left boundary, and now I'm moving my left boundary. So whenever I remove 2, 1 and 2 and 2 and 3 is no longer adjacent. So I have to remove the XOR of 1 and 2 and 2 and 3 from the set. And now 1 and 3 are adjacent to each other. So I have to add the XOR of 1 and 3 to the set again. So XOR of 1 and 3, which is 2, will be in the set, and 1, 3 will be removed from the set too. And whenever I have to find the minimum value of XOR pair in the range, that will be my just first value of these multiple set 2. So that's how I can do a sliding window kind of thing. Uh, Whenever I want to add a value to the set and remove the value from the set. I think it's clear to everyone, like what I was doing. If it was clear, then I I will move to the implementation part. As I didn't implement the code, I was lazy, you can say, and I will implement it live and submit it like it's working or not. So, is it clear to everyone? Like what I explained, this set thing. Just I just explained like how I'm removing and how I'm inserting the thing, because and yeah, I will try to implement the insert and remove function, so we will get a better idea. Okay, so let's implement. So what I'm taking as an input, so n and k, and the okay. So I took the input, and now what we discussed that we can do a binary search on an array. So what I'll do, uh, the my left value for the answer will be let's say 0, and right value, let's say what is my limit to the okay, it's a 10 to power 9. Let's say my right boundary is 1 10, and here is how I do binary search. Uh, and I will keep one answer here. Let's say answer was equal to R first. And if I found that yes, answer can be yes, check is true, then I will update the answer with equal to mid, and I will move my right boundary to the mid -1. And if my check is wrong, it means like the number of sub array which has value equal to mid is less than k, then I have to increase my left boundary. So I will increase by mid +1. And let's say in the check, what I'm passing. So I will pass mid, I will pass an array A, and I will pass n and k. That's it. And let's say here is the bool function of check, which is accepting, let's say, okay, I'm keeping it mid, uh, array A and k, right? Let's say A passed by reference. So, okay. And now in this function, let's say what we discussed, we will create two sets first. So let two multi-sets, because values can be in a there can be multiple instance of some value in array A, because we are not given that every value is distinct. So multi-sets, like let's say S1 and S2. In S1, I will store sorted values of the window, and in S2, I will store the XOR of adjacent in the window, right? And now let's say my left boundary, like I'm starting uh, exploring the every window in the array. And as I discussed that if I found my left boundary, I will just increase the count by L, because every value from 1 to n can be the part of the array, and the XOR will be always equal to the mid if the XOR is less than equal to mid in the range L to R. So I initiate L with 1, as it's a habit of mine that I keep everything in one based indexing. And let's say my count of subarray is 0 first, and then I'm exploring every subarray. So, and let's say, okay, I'm keeping it R. as my right boundary, and r is less than r starting from 1. Okay. Now what I will do, like whenever I go to any, whenever I increase my right boundary, I will insert that in my set 1, and I have to modify my set 2, because no two values will be adjacent after I insert a small values. Those were adjacent before inserting that value. So let's say I am creating one function insert, and I'm inserting AR in the set 1 and set 2. Okay. And I'm again writing the, an insert function will not return anything. So it's just insert. Uh, I'm inserting, let's say, value X, and I'm inserting it in the S1 and in the S2. Okay. So what I will do, like, let's say I inserted X in the S1. So I want the pointer to that position to get the pointer of previous and next position that I will need to calculate the adjacent XOR thing. So it will be S1 dot insert X. That's it. And it will give me the iterator to the position where I inserted X. And now what I have to do, like, let's say this iterator, now I have to check again. Like if the iterator is at the beginning of the S1, and otherwise a iterator can be at the end of the S2, then I will not have previous to adjacent values. Like, let's say here is the set 1 and 3, and I'm inserting 5 now. So 5 will be here. So no, I didn't break any two adjacent value, like 1 and 3 are still adjacent. I just have to insert XOR of 3 and 5 to the set 2. And if there was 3 and 5 and I'm inserting 1, then 1 will go here. So I'm not breaking the XOR of 3 and 5, but I'm just adding XOR of 1 and 3 to the new set. So that's what we have to do if the iterator is at the, if iterator is not at the boundary, like let's say if iterator is not at the boundary, then we are not removing anything from the S2. But okay, I think I have to use pen instead of mouse. Okay. So let's say I'm inserting 1 at the boundary, then I don't have to remove anything from my set 2, as set 2 was containing XOR of 3 and 5. But let's say I'm inserting 4 in this set, then I have to remove the XOR of 3 and 5, because 4 will go at this position. So I have to remove XOR of 3 and 5. So that's what I'm trying to do here. If my iterator is not at the beginning of the set 1, then what I can do, I can, if iterator is not at the beginning, like, let's say I inserted 4 here, 3, 4 and 5 will be my new set. Okay, sorry. Yeah, let's say 3 and 5 was my previous set, and I'm inserting 4 here. So my new set will be 3, 4 and 5, and it's not at the beginning. So I have to add XOR of 3 and 4 to my set 2. And I have, and if 4 is not at the end of the set, then I have to add XOR of 4 and 5 to the set 2. So in this position, if a iterator is not at the beginning of the set, then what I will do, I will just add, uh, I hope you know how to find the previous in the multiset. If I have to find like previous iterator, let's say auto prev it, then I just have to give a pointer it to the prev and I will get the previous iterator. Okay. And I will insert the current value XOR the value at the previous iterator to the set S2, right? I I hope it's clear what I just did here. And the same thing we will do if my iterator is not at the end in the set. Like S1 iterator is not equal to the ending pointer. And just like previous, if I want to find the next iterator, it's just next for set, multiset. And again, I will insert, okay. And again, I will insert just X XOR IT. Now, if my iterator is not at the beginning or at the end, like it's somewhere between. So like iterator is not at the beginning and iterator is not at the end of the set, then I have to erase value of previous minus previous XOR next. So I will take previous value, I will take next value, and what I will do, I will erase it from the set 2, XOR of both of it. So I will erase the value by finding it, because if I just erase the value, then it will erase all of the instance. And I want to erase only one instance. So I will find the value first, which is prev it XOR next it. And I will erase it from the set 2, which is storing the XOR of adjacent position. So I hope the insert function is clear to everyone. And now let's see what we discussed. Let's do as we discussed. So if now let's say my stat2 is not empty, like S2 is not empty, and whenever until when I do not found the best possible L which has the XOR less than equal to mid, until then I have to increase my left boundary and then I have to add L to the answer. So what I'm trying to say, until when my the shortest value of my S2 is my shortest XOR, adjacent XOR, and again it's the cost of the subarray L2R. So until the minimum value of S2 begin is less than equal to mid, I have to increase my left boundary, and as I'm increasing my left boundary, I have to erase the the value of previous L, which is A of L, and again I have to pass S1 and S2. And one thing, like I cannot get the iterator at the beginning of the set if S2 is empty. So I have to add the condition if S2 not need to be empty. Like if S2 is empty, then I cannot extract the position and I can not do this stuff. So let's say how we can implement the erase thing. Like we want to erase X and we have two multiset S1 and S2. Okay. So what we are doing to erase? Like first we have to find the pointer at position X. We just can't erase it because we have to modify S2 accordingly. So let's say pointer is s1 dot find it, s1 dot find x, and after that again the same conditions will go here, but some things we have to differentiate. Like if I'm now erasing, so whenever I erase, I have to erase these things like x XOR it I was adding during the insertion, but now x is removed. So I have to remove the XOR or with the previous and the next iterator from the set 2. I was inserting it because x becomes the new adjacent of the previous and next position. But now it will be going to remove from the set 1. So I don't need the XOR stuff as well. So what I will do is leave here. And for that, I have to find again, as I explained, that if I just erase x XOR it, and it will erase all of the, it will erase all of instance from the multiset. So s2 dot find here, and same for this s2 dot find add. Uh, Now I am removing x, so my previous and next position will become adjacent. So instead of erase, I will insert that thing again. And now I will remove it from the S1. So that's how I will do erase. And if you have any doubt in erase function, let me know. Oh, I think it's need to be x XOR pre it and next it, and here as well pre it and next it. Right. Uh, I hope it's clear to everyone. Let me know in the chat box by writing +1 or yes, whatever you want, so I can move to the next part. Okay. So after moving my left boundary to the desired position, what I will do? I will just increase my count by L, because every position from 1 to L can be the part of that subarray. But okay, here we will go to the L, which is one ahead of the desired position. Like L will be that position where this condition will fail, and for that I have to add L minus 1 to the count. And at the end, what I will check, that is the count greater equal to k or not. And if it's written, just written count greater or equal to k or not, and that will be our answer. And at the end, just print answer. So I think I'm done with the code part. And if you guys have any doubt, ask it in the chat box. I'm testing it with the sample code sample first. Lol, it didn't print anything. Okay, let me check where was the issue. Let's print A here, like this function was called or not. How to check? Okay, A was called. Okay, what was the answer for the first case? It was 1. Okay, where I did the mistake then. Mm, okay, I'm inserting one. Okay, why zero is here? Base to there is no space for zero. Wait a minute, I'm checking my code again. I think I did some mistake and it is going out of the bound. Okay, yes, yes, I got it. Uh, I just can't check it with the AND because AND is the pointer which is the AND of the multiset, and after that it's point to the AND pointer. So I have to check that if the next IT is equal to AND or not. And Sam will go here and again Sam for this case and this one. Okay. Yeah, we got the answer equal to one. Let's remove debug from everywhere and change R to 110 again and copy the sample again and run. Okay, 17123. That's what the output. Let's submit. Okay, it's running on 7, so it needs to be AC. And what was the time complexity if we check? The time complexity of binary search is log n. The complexity of the loop is O of n, and the complexity of insert and erase is again in log n, you can say, because the every operation find and erase took log n time in set. So the overall time complexity is n into log n, and the check function is running inside the binary set. So it's n into log square of n, and yeah, we got SE in our code. So I hope the solution and the code was clear to everyone. So okay, and for the problem G, I didn't solve the I didn't write the code of problem G again because of laziness, and the code of G was cancerous. Uh, I think G is of the difficulty around 3000, so it's too hard to code if you guys also have the solution. And I think I have a skill issue to explain the solution. Mm, okay, what I'll try, once I will code the problem G, I will try to create a recorded solution because I need time to how I explain the solution, so that you guys can understand. So, and I will upload that recorded solution as soon as I code, and I'm a bit lazy to code the solution. So I will call these. Okay, I think we can end the stream now for it, and I hope you understand E and F. And if you guys have any doubt in the solution of E and F, you can ask. And if you have any doubt in the implementation of F, yes, you can ask it as well. So was it clear, guys? Just write yes or no in the chat box. Okay. I think no one has any doubt. Uh, we can end the stream. Ayush, if you are there, please end the stream. Okay, I'm not getting chat here. I think people were writing, but I'm not getting in the mobile. Wait a minute. Let me. Okay, I defined int long long there. And okay, yes, Chinmay, you mentioned that it need to be next IT is not equal to and. I didn't get the live chat in the mobile because of some issue. But yeah, I'm reading it. Yes, I defined int long long in my snippet here. So, and that's I defined because I don't want to, whenever want to declare like a 1 in 10, 1 in 18 thing. So yeah, it's just a bit of habit for me. Okay. Any doubt? Again, if you have any doubt, just let me know. Okay, I think we can end the stream. Thank you for joining,
Fine.
guys, and I will try to add the recorded solution of G as soon as possible. Uh, Ayush,
Okay.
we can end the stream now.
Fine. Also, there won't be any session tomorrow from the novice camp. It will be postponed till next weekend, maybe. We'll put in the
Okay.
announcement.
Instant gaming, does defining int long long reduce the speed? Yes, it will reduce the speed. And in a task where you have to do too many operation of some subtraction, divisor, multiplication, modulo, there you will get feel of that speed because I got once TLE just because of long long because long long is of 64-bit and it using double time to do every operation than integer, and because of that we get sometimes TLE because sometimes 2 into n is sometimes like a, let's say n is equal to 10 to power 6, and 10 to power 6 into, let's say, 20 is, let's say, 200 is 2 into 10 to power 8, right? And if I multiply it by 2, it will take around 4 seconds if my operations are not optimal. So yeah, in those case it will cause an issue. Anyone has any other doubt or any general doubt, like apart from the problems for CP? And also, I like to say like modulo is too much time consuming in process because if you do sum without modulo, then it will run in almost 1/10 time sometimes. So yeah, modulo is time taking, and there are ways to do fast modulo or to remove modulo thing. So yeah, you can explore that as well. Okay, I'm ending the stream now.